In February 2025, NASA updated the impact risk assessment for asteroid Bennu. No press conference, no headline, just a quiet revision buried inside a technical database that almost nobody outside of planetary science ever opens. That same month, NASA's Solar Dynamics Observatory confirmed that solar cycle 25 had already blown past every peak intensity forecast ever made for it. 2 events, weeks apart, 0 front pages. You were not supposed to connect those 2 things. Most people never will. But here's what happens when you do. Everything you're about to hear comes from NASA's own published data, congressional hearing transcripts, and peer-reviewed journals. No speculation, no unnamed sources. Every single claim in this video has a document behind it that you can pull up yourself. This channel exists for one reason: to find the real science buried inside technical reports and government abstracts, and break it down so that any thinking person can understand exactly what is happening up there. If that is what you're here for, subscribe right now, because what is coming in the next 20 minutes is only the beginning. Before we go any further, I want to ask you something personal. When you were growing up, did you genuinely believe that NASA was telling us everything? That every discovery, every risk assessment, every anomaly detected by their instruments was being communicated clearly and completely to the public? And if something changed your mind, I want to know the exact moment it happened. Was it something you read? Something that simply did not add up? Drop it in the comments right now. I read thousands of responses from people all over the world, and I want to know exactly where you stand on this. Picture a Tuesday morning in Pasadena, California. A navigation engineer sits down at his desk at NASA's Jet Propulsion Laboratory. His name is Dr. Davide Farnocchia, and what he is doing, at least on the surface, sounds completely unremarkable. He is updating orbital calculations for asteroid 1011955 Bennu. This is standard procedure at JPL. Spacecraft collect data, that data gets fed into trajectory models, and engineers like Farnocchia refine the numbers. It is the mathematical equivalent of housekeeping. Nobody expects surprises. The models get marginally better and the work moves on. But in early 2021, the data Farnocchia was working with was different from anything that had come before it. The OSIRIS-REx spacecraft had spent 2 years in close orbit around Bennu, collecting measurements of extraordinary precision. The asteroid's exact shape, its surface composition, its rotation rate, the subtle way sunlight was pushing against it over time. It was the most complete dataset ever assembled for any asteroid in human history. Farnocchia fed that data into the model, and the model returned a number that stopped him. Bennu's probability of striking Earth had increased, not dramatically, not in the way that triggers emergency protocols or classified briefings, but statistically, meaningfully, undeniably, the numbers had moved in the wrong direction. The updated calculation placed the overall impact probability at 1 in 1,750 across a risk window stretching from 2,175 to 2,199. That single figure made Bennu the most statistically significant impact threat in NASA's entire catalog of tracked near-Earth objects. Every other asteroid on the list sat below it. Farnocchia and his team documented everything carefully and submitted their findings for peer review. The paper was published in the journal Icarus in August 2021. It received almost no mainstream media coverage. Think about what that means for a moment. One scientist, one updated calculation on an otherwise ordinary Tuesday. And the result was a number that carries direct implications for the long-term survival of every person on this planet. The work continued. The number sat in the database. And almost nobody noticed. That should have been the end of the quiet part. It was not. Here's the problem with predicting exactly where an asteroid will be 150 years from now. It is not that we lack the technology, it is that the universe operates on a level of precision that makes even our best instruments feel blunt. Every asteroid moving through the inner solar system is subject to a force so small that scientists assumed it was negligible. It is called the Yarkovsky Effect, and it is quietly one of the most consequential phenomena in all of planetary science. The mechanism is straightforward enough. As an asteroid rotates, sunlight heats one side of its surface. As that side rotates away from the sun and into shadow, it radiates that stored heat back out into space as infrared energy. That radiation creates a tiny thrust, not enough to feel, not enough to measure casually, but enough, accumulated over decades and centuries, to push an asteroid meaningfully off its predicted path. For most asteroids, measuring the Yarkovsky effect is effectively impossible. To calculate it accurately, you need to know the object's precise variables. For a rock tumbling through deep space millions of kilometers away, assembling that complete picture was, until recently, simply beyond our reach. OSIRIS-REx changed that for Bennu. 2 years in close orbit, thousands of measurements, the most complete asteroid dataset ever collected. And even armed with all of that data, the uncertainty range in Bennu's projected position in 2182 is still measured in hundreds of thousands of kilometers. That uncertainty range contains Earth. It also contains empty space, We do not yet know which one Bennu is heading for. Then, in 2025, NASA's Center for Near-Earth Object Studies quietly updated its Sentry risk table. New computational models were applied. This was not classified. It was not hidden. Every update is publicly available to anyone who knows where to look. Almost nobody looks. And that gap between the data and the public is exactly where this story gets uncomfortable. On September 26, 2022, at 7:14 in the evening Eastern Time, a spacecraft the size of a vending machine made contact with an asteroid moonlet, traveling at 14,000 miles per hour. The collision with Dimorphos was deliberate. It was humanity's first real attempt to prove we could move a rock in space. The mission was called DART, Double Asteroid Redirection Test. The target, Dimorphos, is a 160-meter moonlet orbiting the larger asteroid Didymos. Dimorphos posed no threat to Earth. It was chosen precisely because it was safe, a test subject for a technique that may one day matter enormously. The mission's success threshold was modest. If DART changed Dimorphos' orbital period by at least 73 seconds, it would be considered a success. The actual result was 33 minutes, more than 3 times beyond what the mission needed to achieve, and larger than pre-impact models had forecast. The results were documented in 5 peer-reviewed papers published in the journal Nature in March 2023, but buried inside was a surprise. The majority of the deflection force did not come from the physical impact. It came from the recoil of ejecta, a plume of debris. This debris blasted off the surface like exhaust from a rocket engine, pushing the asteroid in the opposite direction with far greater force. This changes everything about future missions. The spacecraft is not the weapon. The surface material of the asteroid itself is the weapon, if you hit it correctly. We now have proof that this works. Peer-reviewed, published, repeatable proof. And yet, here is the number that reframes that achievement entirely. In a 2024 congressional hearing, NASA's Planetary Defense Officer, Lindley Johnson, stated that current ground-based telescope networks have detected an estimated 40% of all near-Earth objects larger than 140 meters, the threshold above which an impact can cause regional catastrophe. 40%. That means 60% of the rocks large enough to level a city or trigger a coastline-destroying tsunami are currently untracked, unnamed, and invisible. To every system we have. The NEO Surveyor spacecraft, scheduled for launch in 2027, is designed to push that number toward 90%, but it is not launched yet. Right now, today, the majority of the threat is invisible. If you are the kind of person who believes that understanding the real science matters more than a comfortable headline, drop a like on this video. Not for the algorithm, not for me. Because this kind of factual, sourced, no exaggeration content only reaches the people who need to see it. You are clearly one of those people. So hit the like button and let's keep going. In 2019, a panel of international scientists convened jointly by NASA and NOAA sat down to forecast the behavior of solar cycle 25, the current cycle of solar activity that had just begun in December of that year. Their conclusion was measured and confident. Solar cycle 25 would be below average. It would peak at a sunspot number of approximately 115 around July 2025. It would be, in their own framing, unremarkable. That forecast is now effectively obsolete. By mid-2024, solar cycle 25 had already surpassed that predicted peak by a substantial margin, reaching sunspot numbers above 150. Numbers that high had not been recorded since solar cycle 19 in the late 1950s. Dr. Lisa Upton of the Southwest Research Institute and Dr. David Hathaway, formerly of NASA, both revised their models upward. The cycle was not only stronger than predicted, it was showing signs of lasting longer than the original forecast had accounted for. Then, May 2024 arrived. A cluster of X-class solar flares erupted from a region of the Sun designated Active Region 13664. What followed was a G5 geomagnetic storm, the highest classification on OAA's 5-level scale, the most powerful to strike Earth since 2003. Auroras burned across skies as far south as Florida and Texas. Power grid operators across North America issued emergency alerts. GPS accuracy degraded across large portions of the Northern Hemisphere for hours. NOAA's Space Weather Prediction Center documented every minute of it in real time. This was not a fringe event reported by alternative media. This was a fully verified, institutionally recorded geomagnetic storm of the highest possible classification. And the cycle that produced it has not yet reached its true maximum. That is, Discovery 1. And it would be alarming enough on its own. But it is not on its own. What makes a powerful solar maximum genuinely dangerous is not the light. Light from the sun reaches Earth in 8 minutes and powers life on this planet. The threat is what travels with the light during extreme events, coronal mass ejections, or CMEs. Massive eruptions of magnetized plasma that, when directed at Earth, compress our planet's magnetosphere and induce powerful electrical currents inside anything long and conductive on the surface. power lines, pipelines, submarine communication cables, railroad tracks. As we approach the peak of solar cycle 25, the risks to our modern infrastructure have never been higher. The historical benchmark for this threat is the Carrington event of September 1859. A solar storm of such intensity that telegraph operators across North America and Europe reported their machines producing sparks and catching fire powered entirely by the induced current from the storm, with no electricity supply connected. Some operators unplugged their machines from the power supply and found the lines still functioned, driven purely by the geomagnetic disturbance overhead. In 2013, a report produced jointly by Lloyd's of London and the Atmospheric and Environmental Research Group estimated that a Carrington-level event striking Earth today would cause between $600 billion and $2.6 trillion in damage in the United States alone. The primary driver of that estimate was not burned electronics or disrupted communications. It was the destruction of high-voltage transformers, the massive custom-built components that form the backbone of the power grid, each one taking between 1 and 3 years to manufacture and replace. A 2008 report by the National Academy of Sciences warned that a severe geomagnetic storm could leave 130 million Americans without power for months, possibly years. These reports exist. They were presented to Congress. The power grid remains almost entirely unshielded, and solar cycle 25 is still climbing. Here is where the individual threads become something larger and harder to dismiss. In 2025, 3 separate verified developments are operating simultaneously. Bennu, the highest statistical impact threat in NASA's catalog, has a critical gravitational keyhole encounter with Earth approaching in 2135. Solar cycle 25 has already produced the strongest geomagnetic storm in 21 years, with its true peak still ahead. And NASA's planetary defense officer confirmed that 60% of near-Earth objects large enough to cause regional catastrophe remain completely undetected. Individually, each fact is manageable. Together, they represent something this planet has never faced before: 3 planetary-scale threat systems running simultaneously. That convergence has no historical precedent. And it did not make a single front page. Step outside for a moment. It is an ordinary afternoon. The sky is clear, then it is not. Above you, something begins that has no modern reference point. The aurora does not appear at the horizon like in Norway. It fills the entire sky, not green, red and white, shifting violently. It is visible at noon in Dallas, London, and Mumbai. Simultaneously, people are stopping in the street and looking up. Your phone goes dark, not low battery, not a dropped signal, simply dark. The plasma cloud has scrambled every GPS satellite signal. You cannot navigate, emergency services cannot coordinate. Aircraft instrumentation is degraded across flight corridors. Then the power goes out. Not your block, not your neighborhood, your entire region. The transformers that form the backbone of the grid are burning. Components that stand 12 feet tall weigh hundreds of tons and take up to 3 years to manufacture. There are no replacements. There's no fast solution. These threads are coming together now in a 5-year window, while public attention sits elsewhere. That convergence has no historical precedent, and it did not make a single front page. Step outside for a moment. It is an ordinary afternoon. The sky is clear, then it is not. Above you, something begins that has no modern reference point. The aurora does not appear at the horizon the way it does in photographs. It fills the entire sky, not green. Red and white, shifting violently, folding over itself in curtains that move faster than clouds. It is visible at noon. It is visible in Dallas, in London, in Mumbai. Simultaneously, on every continent, people are stopping and looking up. Your phone goes dark. Not low battery, not a dropped signal, simply dark. The plasma cloud, now compressing Earth's magnetosphere, has scrambled every GPS satellite signal above your horizon. You cannot navigate. Emergency services cannot coordinate. Aircraft instrumentation is degraded across entire flight corridors. Then the power goes out. Not your block, not your neighborhood, your entire region. The transformers that form the backbone of the grid, components that stand 12 feet tall, weigh hundreds of tons, are burning. There are no replacements waiting in a warehouse. There is no fast solution. The lights are not coming back next week. That is one scenario. It is grounded in documented historical precedent. Now shift your perspective entirely. 200 million kilometers from where you're standing, a rock the size of a small mountain is rotating silently. Bennu, 500 meters wide, covered in loose rubble and boulders so unstable that the ground behaves less like solid rock. When OSIRIS-REx attempted to briefly touch its surface, the spacecraft sank slightly, more like a ball pit. It completes one full rotation every 4.3 hours. It drifts, it absorbs sunlight on one side and radiates heat on the other, nudging itself by millimeters per year along a path that will bring it within 125,000 kilometers of Earth in 2135, closer than the Moon. At that distance, Earth's gravity becomes a decision maker, Depending on where exactly Bennu passes through a precisely mapped gravitational keyhole, the trajectory for 2182 curves safely away, or it does not. That decision has not been made yet. The math has not resolved. The rock keeps rotating. Let us put actual numbers against what we are talking about. A Bennu scale impact would release approximately 1/200 megatons of energy. To put that in terms that land physically, that is roughly 80,000 times the yield of the atomic bomb dropped on Hiroshima in 1945. Not 80 times, not 800 times, 80,000 times. Consider Tunguska. On the morning of June 30th, 1908, an object estimated at just 50 meters across entered Earth's atmosphere. It exploded before it ever reached the ground. The blast flattened approximately 2,000 square kilometers of forest instantly. Every tree in an area larger than a major city was knocked flat. There were no casualties because it struck an empty place. Bennu is 10 times larger in diameter than the Tunguska object. But size and destructive energy do not scale linearly. Because mass increases with the cube of diameter, Bennu carries approximately 1,000 times the impact energy of the object that leveled Siberia. Now hold that number alongside this one. A spacecraft the size of a vending machine changed an asteroid's orbit. Peer-reviewed. Published. Independently verified by ground-based telescopes on 4 continents. We have the warning, we have the proof. What we do not yet have is the sustained institutional urgency that a threat of this mathematical scale arguably demands. The gap between what science knows and what the world is doing is the most important contrast in this story. This planet is 4.5 billion years old. In that time, life has been nearly erased multiple times. The asteroid that ended the dinosaurs 66 million years ago arrived without warning, without any creature possessing the ability to stop it. The volcanic winters that pushed early mammals to the edge of extinction, same story, no warning, no comprehension, no choice. Today, we have the science and the means. The choice to act is finally ours. Every mass extinction in the geological record share one thing in common. The life that was lost had absolutely no say in the matter. We are the first species in 4.5 billion years for whom that is no longer entirely true. We detected Bennu. We calculated its probability. We built a spacecraft, flew it across space, and moved another asteroid to prove the method works. That is not a small thing. By any measure of cosmic history, that is an extraordinary thing. And yet, here we are, largely distracted. Many people watching this video will not read these events purely as data. Across traditions spanning centuries and continents, signs in the heavens carry meaning that no scientific paper can fully address. Whether you read what is happening in 2025 as a data set or as something more, the underlying fact remains identical. Something significant is occurring. It is documented. It is verified. And most people have no idea. In 2029, asteroid 90942, Apophis, a 370-meter rock, will pass within 31,000 kilometers of Earth's surface, closer than the satellites currently running the GPS on your phone, close enough to be visible to the naked eye from parts of Europe, Africa, and Asia, a mountain drifting visibly across a clear night sky. But what happens during that pass determines everything that comes after it. If Apophis moves through any one of several precisely mapped gravitational keyholes, its trajectory for the 2036 return pass changes. The next video covers Apophis in full, including the data that almost every mainstream coverage of this asteroid has quietly left out. Do not miss it.